Good morning. It's still morning, and welcome. So today's session is entitled Local Variable Type Inference, Friend or Foe. So I'm Simon Ritter. I work for Azul Systems.
I'm Stuart Marks. I work for Oracle on OpenJDK core libraries.
So the idea behind this presentation is I am going to explain to you all about local variable type inference. We will talk about what are the good things. We will talk about situations where you may not want to use local variable type inference, and then Stuart is going to correct me. That's the general idea.
I tried to make sure his slides were right beforehand, but you know how it goes.
Yes. I think this time we've got every typo. This is a challenge for you as the audience to spot any typos that we have missed. Okay, so the first question that we need to ask ourselves is, why do we need local variable type inference? Because thinking about it, Java is, 24 years old now, and we haven't had local variable type inference until now. So why do we need it? And I think the first logical answer to that question is, well, JavaScript has it, so it must be good. Not sure that's actually a good reason, is it? But anyway, other languages have this feature, so it must be something that we should look at. But the important thing is that we already have a situation where we hide intermediate types, and streams is a very good example of this. So we chain together a number of method calls, and we don't care about what the types are that are in between those method calls. So, we're taking a set of names, we're creating a stream from that, which is a stream of strings, then we filter that, still a stream of strings, then we map it, and we turn it into a stream of records, and eventually we get an array list of records. But we don't care about the intermediate types there. So why not expand this idea to other places? One of the other good things about var is the fact that it can make your code more concise, and we'll see some examples of that as we go through. But again, the important thing is that making your code more concise, but without sacrificing the readability, because we all know that you're going to spend more time reading code than you are writing, so let's not lose any of the readability that we already have. Oh, sorry, yes.
Okay, a couple quick comments on this. I think one thing that's interesting about this streams example, as Simon points out, is that when you chain methods, the intermediate types do not appear explicitly in the code. And so one of the objections that we hear to, oh, you shouldn't introduce var because types need to be explicit. Well, that's not necessarily true. There are times when the types of things are not necessary to the understanding of the code, and that's when var is useful. The other thing is, and we do cover this a little later on, but I think since we mentioned JavaScript, it's good to mention at the outset that Java is still statically typed. So JavaScript has var. JavaScript has a completely different type system. It's dynamically typed. We're not turning into JavaScript. Oddly enough, that is something that people say, oh my gosh, Java is going to be terrible. It's going to be just like JavaScript. No. What happens with var is that a static type is established at compile time, end of story. So it's still statically typed. There's essentially no changes to the type systems.
Yes. Okay, so let's look at some simple uses of var. Now, this is a typical piece of code that we might write, where what we're going to do is we're going to create an array list to store some objects in. So in order to do that, we define our variable userList, and we have to say what type it is, so the compiler understands that it is an array list of type string. And then in order to assign that to something, we're going to instantiate a new array list, and in this case, we'll use the diamond operator to let the compiler do some type inference, because it knows that the array list that we're defining is one of type string, so we don't need to specify that a second time. So we've already got some type inference going on there. And then we can derive a stream from that using the stream method call, and again, we have to specify explicitly that the type of that is stream of type string. We can use a for each style loop as well, and we can say, okay, for, and then we can iterate over the user list, and we can explicitly state that the name that we're going to be using as the variable is of type string. And the last example is that if we want a simple loop, we can say for int I equals 0, I less than 10, I plus plus. Now, we can then replace some of this with var. So now we can let the compiler do more of the type inference. In this case, we'll say, okay, user list is a new array list of type string. So the compiler is obviously going to know that what we're assigning is going to be an array list of type string. You'll notice there's one small change in there, but we'll come back to that a little bit later on. So we can use var, and it's very obvious that what we're assigning is an array list of type string. Similarly, because we use stream directly below that, we can say var stream, and we can let the compiler understand and infer for us that because we're using the list that we have, then the stream that we get from that will be a stream of type string. So that's all good. Similarly, for our for each loop, we can do the same thing. We can say for var name, we don't have to explicitly state the type, or iterate over user list, and the compiler, because it knows that user list is a list of strings, then it can infer that name is going to be a string. So this is all good. Then the last example, we can replace int with var, and we can say for var I less than 10, I++. Now this, I believe, is not a good use of var. The reason I say that is because int has 3 letters in it. Var has 3 letters in it. We save nothing by using var in that particular case, other than making it harder for us to understand what the code is doing. Would you agree with that?
I think that's sensible.
Yes. Okay, some other simple uses of var. Now, this is one where we can sort of clean things up and make code more readable. So what I've done here is I've created a try with resources block, and I've deliberately made it a little bit more involved than I might have done. But you can see here what I'm doing is I'm creating an input stream from a socket, then I'm creating an input stream reader from that input stream, and then finally I'm generating a buffered reader, which I'm going to use within the body of that block. And clearly then all of those things will be closed by the code automatically. But if you look at that code, it's very verbose. There's lots of letters in there, and it's quite confusing because you're seeing input stream reader, and buffered reader, and lots and lots of repetition of things. What we can do is we can clean that up very nicely by using var. And so if we do that, it simplifies out a lot of the code, and it becomes much easier, in my opinion, to read. And we can see immediately that, okay, so input stream is getting the input stream reader, buffered reader, and just tidies up the code and makes it easier to see what's actually going on. Where?
Well, we'll talk after.
Where did I get a typo?
Okay.
Okay.
Can I
Yeah, sure.
interject something?
Well, I look for the typo.
So one thing that's interesting here is that now notice there's a little bit more the weight of understandability is placed more on the variable names. Since we no longer have the explicit types, the names are more prominent. And so it's a little more important to choose good variable names when you're using var.
Okay, I'm still not seeing the typo.
Okay, well.
Oh, man.
Sorry, I noticed the typo on the first slide. We'll talk later.
Okay. Now, and Stuart already mentioned about this, which is that we're not losing any of the static typing that we have in terms of Java as a language. So in the case of assigning a value here, what we're saying is var name equals Simon. Okay, so the compiler will obviously infer that that name is a string because we're assigning a string to it. So that's very simple. And what we can then do is, because we haven't made it final, we can change its value. And so we could assign Dylan to the name, and it's still a string. So there is absolutely no problem with that. But unlike with JavaScript, as you said, if we were to try and assign a different type to that variable, then we would have a problem, because 42 is not a string, and even with auto boxing, you couldn't convert it into a string. No, you couldn't. So you've got a wrong type there, and so the compiler will give you an error when you actually do that.
Yeah, that's right.
Right, final and non-final. So the important thing here is that var simply indicates that the compiler is going to infer the type. It doesn't make any assumption about whether that thing is final or non-final. So it doesn't make it a final variable. So again, we can say var name equals Simon, and then we can change the value of that, and it's completely valid code. We don't have to worry about that at all. If we were to want that thing to be final, then we explicitly have to add the final modifier and say final var name equals Simon. And again, that will then make the variable final. This is where some people have had a discussion about this. And so the idea is that some languages have both a var and a val, where val makes the thing final automatically, and you don't have to explicitly state that as a separate modifier. So you can have var and modify the variable val, and it becomes final. So the thing that some people have asked is, well, why didn't you add val as well as var? And there are a number of sort of things that you can argue in terms of why you wouldn't want that. I mean, one of the things that some people have said to me is, well, how often do you make local variables final? And yeah, some people do, some people don't. Do you want to add something to that?
Yeah, I think the comparison with Kotlin and Scala comes up. And if you look at the syntax of variable declaration, you can choose var versus val completely in those languages, Kotlin and Scala. You can choose var versus val completely independently of whether you declare a type explicitly or whether it's inferred. Whereas var is actually, even though it's the same word, it's performing a completely different role in Java. It's replacing the explicit type. And so it just doesn't work the same way as in Scala and Kotlin. So I think a better example, or better comparison, is C#, which has var, which essentially does the same thing. It infers the type. And there's no val in C# as far as I know. Right. I don't know about Groovy, so what?
Okay. Right, action at a distance. So this is one of those situations where you need to think a little bit carefully about whether it makes sense to use local variable type inference or not. Because if we do something like this, where we say var L equals new array list of string, and we use var S equals L dot stream. Now in the case of S, because we actually create that variable directly below where we've instantiated the array list, it's pretty obvious that without having to use the IDE to hover over it and find out the type, we can immediately see that L is going to be an array list of string, and so S is going to be a stream of strings. But if we then had a whole bunch of code, and we sort of did lots of stuff, and then finally we've gone down here and we say var n equals L dot get 0, then we're faced with a bit of a problem because it's not immediately obvious what the type of n is going to be, because we've used a rather bad choice of name for our array list, just calling it L. Doesn't really give us any indication of what that's going to be. So if we had, var usernames, then at least that would give us an idea of, okay, it's names, so it's probably going to be string. But by giving it the name L, if we do this at a distance, then it becomes harder to understand what's going on in the code, and it doesn't aid readability. Did you want to add anything to that? No, sure. Jumping variable names. This is, again, a sort of idea behind how we can simplify our code. And this is a contrived example, but what I've done here is to use deliberately quite verbose type names and ended up with this quite complicated bit of code where, again, it's verbose, it's difficult to read because we've got lots of repetition of the types that are involved. And by using local variable type inference, that cleans up again. Very nice, we can line up things, and var is fixed in length, so then we get a much clearer idea of what's actually going on. Right, not everything can be inferred. So this is quite an interesting one here. So let's say that we have an array of ints, which is the first 6 primes, and I've got this right this time. I know I've got
You left out 9. 9 is prime.
Don't say that. It's not. Okay, so we've got this array of ints, which is the first 6 primes, and obviously we define that as an array by using our braces, and we say 2, 3, 5, whatever. What we might want to do is try and use var for that. So we can say var, first 6 primes, and we assign to that the array of ints, which is 2, 3, 5, and so on. However, that won't work. If you try and do that, you will get error, cannot infer type for local variable first 6 primes, and it says array initializer needs an explicit target type. So I want you to talk about this one.
All right, so there's a little clue embedded in there, which is that the error message says target type. And so let's just focus on the initializer portion of this declaration, which is the numbers within brackets. So we have bracket 2, 3, 5, 7. So those are integer literals. So you'd think if you had those in an array, that would be an int array, right? Okay. Well, not really. You could also say byte bracket bracket first 6 primes equals brace 2, 3, 5, and so forth. And that would work. And the reason is that the type of that array initializer is not established by itself. It needs to have a context in which the array elements get their type from the context. And the context is called the target type. So if you say byte array, or, array equals 2, 3, 5, 7, 11, right? Those are bytes. If you say short array for 6 primes equals 2, 3, 5, 7, right? Those are shorts. And so you actually have, I don't know if we actually called it type inference, but those array initializers need additional information in order to get a type for that array. And so the problem here is that if we say var first 6 primes equals this array, what's the type of those things? Well, we don't know. We need to look for a target type. Well, var says infer the type from the other side. So basically, we have the statement saying, okay, hey, I need to infer the type from you, and there's just not enough information there. So we could have made some arbitrary rule that said, well, those are ints, but after some analysis, we felt that was a little error-prone. And so in cases like this, if you want to have an array initializer, it's probably best just to explicitly declare the array and not allow the use of var in this case.
I'm going to come back to this on this.
Okay.
I'll come back to you on this one a little bit later on, because I think there's another thing that we need to discuss.
Okay.
Aha. Initialization is required. So in this case, we could say var list equals null. So let's have a show of hands. Who thinks that that is valid code? Okay, so I guess because I'm yes, I know. Because I'm asking the question, you're going to go, no, it's not. And the answer is it's not. So you would actually get var list equals null, variable initializer is null, so you can't infer the type for that. Now, when I look at that, I think to myself, okay, so null to me is a null reference to an object, because we're dealing with a type, so the superclass of all classes is object. So wouldn't it be logical to say that the compiler could legitimately infer that list, in this case, is an object, and then it just assigns null to it? That would work, but that is not the case, so I will let you explain.
Okay, so officially the way the type system works in Java is null is a literal which indicates the lone value of something special called the null type. And it's a little weird because you actually can't write the name of the null type in Java. But the null type is what we call a bottom type, which means it is assignment compatible with every reference type. And so implicitly everybody knows this. If you have a string, you can say string foo equals null. If you have big integer x equals null, all of those things work because what happens is the null reference is converted, the null literal is converted from the null type to any reference type. So there's this question here, which is, okay, if you initialize something to null, okay, well, it's probably not useful to infer the type of this variable as the null type because the only value that the null type can possibly have is null. So
because you then couldn't assign it to anything
You could never
else.
assign it to anything else.
Yeah.
So it's like, okay, well, we probably don't want to do that. Well, so there's this whole space of reference types, any object. It's like, well, there's no information to choose which one of those. And so the other obvious choice is object, right, because that's the super type of all reference types. So we could have done that, and that would have worked, as Simon said, but there was a design decision the language designers made, which was, that's probably not useful either, because if you're initializing some variable to null, you actually don't use local variable references of object all that often. Usually you might want to have some specific reference type, and if you want to initialize it to null, that would be fine. But then later on, you assign it to something else. And so you don't use the object type that way typically in Java programs. So we said, inferring object in this case is probably not a good idea. So anyway, so if you look at the space of possible solutions for what type could be inferred in this case, it's like there aren't any really good choices. So we said, actually, this is probably something that we don't want to support. So hence, we decided to make it an error.
Yes. I think when we did this before, you gave a very nice explanation, which is if you think object is the supertype of all subtypes, and then null is kind of at the bottom, and it's possible to represent any type.
Yeah, it's like a diamond.
Yes.
You have null at the bottom, and then all the types, and then object at the top.
Yes. Again, initialization is required. So you might think to yourself, well, okay, let's define var list, and then we'll say list is a new array list of type string on another line. So logically, you'd think, okay, well, the compiler could go, okay, I see list, I see array list of type string, so couldn't we infer that that type is array list of type string? And the answer is no. So you cannot infer a type for a local variable list. It has to be, it's variable without an initializer. So you have to initialize it on the same line. In fact, yes, let's move on to the next slide, because the problem is, you see, if you were to do something like this, where you said var list, and then you could have list equals new array list of string, list equals 42, and then you end up with a problem of what type would the compiler try and choose, because if it's not assigned immediately, then is it going to be an array list of type string? Is it going to be an int? Is it going to be an integer? Is it going to be an object? You know, again, technically, object would work with all of with that. Would it? Yes. Yes, it would.
Yeah,
just.
I think so.
Yes. Yeah. But the problem is it then becomes ambiguous, and so the choice has been made that you have to initialize when you define the variable. Literals with var. So this is, we're going to come back to what we were talking about earlier. So this is good examples of where you can use literal with var. So in this case, we've got four variables that we've defined. Boolean ready equals true, okay. Char ch equals x, long sum equals 0 L, so we've explicitly made it a long, and string label equals foo. So in this case, we could use var, and there is no ambiguity, because ready is obviously a Boolean, ch is a character, sum is a long, and label is definitely a string. So there's no ambiguity, all that works very nicely. However, this is where var gets dangerous with literals, because if we have this situation, so we have byte flags equals 0, short mask equals 0x7fff, and long base equals 10. Now, what we could do is we could write some code where we use this information and then we write it to a file. So we write flags, mask, base to a file, and we store that information. Then we want to read it back again. So we know that we're reading a byte, we're reading a short, and we're reading a long. So we know the size of those those values in terms of the number of bits, and that will work. If we were to do that, and then we came along and we changed it to use var, that would break our code, in the sense that suddenly var will infer all of these to be int, because the value that you have there will fit into an int. So that would mean that if you had written them out as byte, short, long, and you tried to read them back using these variables, then suddenly you'd be trying to read 32 bits, 32 bits, 32 bits, and that wouldn't work with what you've got stored in your file. So this is where I come back to what we were talking about earlier with the array of ints, and you said that we don't infer the type because they could represent, you could have a short array or a byte array. Why doesn't that get rejected?
Well, okay, so wind back to the previous slide. Right, so here's an example of what I was talking about. Byte flags equals 0. 0 is an int literal, but how does it work if you're assigning it to a byte? So there's actually a special section in the JLS that talks about compile time type conversion. It says, okay, so 0 is an int literal, but if it's initializing something that's not an int, then the compiler will convert it to the proper type if it fits. And so if you say byte flags equals 1,000, that's compile time error, because it cannot convert 1,000 because 1,000 does not fit into a byte. So there's some special casing going on here in the language, and that interacts badly with var.
Okay. Beware of multiple type inference. So in the very first example, I kind of skipped over a change that I had made in terms of the code to keep it working correctly. We can do this. So if we had our item queue, so let's say priority queue of strings item queue equals new priority queue, and we use the diamond operator to let the compiler do type inference. If we were to just go through and do a global search and replace and take out the first bit, the first type, and replace it with var, we have a bit of a problem, because we're seeing type inference being used twice. In the first case, the diamond operator is inferring the generic type of our priority queue. And then we've got a secondary type inference where the var reference means that we have to infer the type of item queue. Now, in order for that to work, obviously the compiler has to figure out what type is going to be used there, but we haven't defined any information that would give us the ability to do that. So in this case, it will say object, because object is the supertype of all types. So the only thing that we can infer correctly for that, given no other information, is object. Object will fit, and then we get an item queue, which is inferred to be a priority queue of object, rather than what we would have had before if we explicitly stated the generic type. So do you want to say something about that?
Right, okay, so a couple things. So it's like, well, why isn't this an error? Is a
Yes,
common thing
that would be
comes
my
up.
first
Yes.
question.
So one of the things is that, so the diamond operator, or the diamond style type inference was introduced in Java 7, and so that predates var by quite a bit. So var did not exist at that time. So in that context, the way that diamond type inference was done was, okay, so it looks for various places for information, and if it can't find sufficient information, the rule was, okay, well, then it will be, the type inferred will be object. And so that rule was in place since Java 7. So now if you use that with var, we didn't want to change the rules and say, well, it's not inferred as object anymore because of something else. And so they said, okay, let's leave these rules in place. And so if you use it with var, then diamond will still infer object. And you can use it with var this way, but probably this is not what you want. So this is something that, anyway, so it's basically a compatibility issue. We didn't want to change the type inference rules of diamond. We just wanted to add var in as an additional thing. But this is an unfortunate interaction between these two features.
Good. So that explains that very well. I think the only thing I would say to that is it would have been nice if it just at least printed a warning.
Yeah, good question. Maybe there's a way to get the compiler to issue a lint warning on that. I'm not entirely
just
sure
because
about that.
you know it's going to be the kind of thing that will catch people out when they're going
Right.
through and just changing things and forgetting that they're using the diamond operator. Right. Yes.
Oh, did we want to talk about how to avoid this case? Let me talk
please
about
do.
that. Yeah.
Yes.
So if you have this, it's like if you want to create something, right? Really, the solution here is you provide more type information in the right place. Either don't use var and make an explicit type on the left-hand side. Sorry. Or fill in the diamond, and that's what Simon did earlier, if you remember that example, where he used new array list of diamond, and then he converted it to var, and he said new array list of string.
Yes.
Right, so you can fill in the diamond. Or if you provide arguments to the constructor, then that can provide some type information that will let diamond do it. Was that a giveaway?
Yes. Don't say anymore. Right, reserved type, not keyword. So this is important because obviously introducing var to the Java language, you might think, hang on, if we're now using var as effectively a keyword, then won't that potentially break a lot of code? Because show of hands, who here has ever used var as a variable name? Come on, own up, you have. Right. Well, it's not a reserved keyword. It is a reserved type. And that's an important, subtle distinction, because it means that you can still do this. You can have var equals new value-added reseller. That is perfectly legitimate code, and there's no problem with that. The compiler will parse that and process it correctly. However, what you can't do in JDK 10 and later, which you never would have done in JDK 9 and earlier, is to create a class called, so that works, is to create a class called var with a lowercase v. So that is valid Java syntax, but you wouldn't have done that. So you can't do that now, so that doesn't work. But you can still create a class called var with an uppercase v, which is what we always would have done, so that's fine. Right, programming to an interface. Now, this is obviously a common way that people write Java code, which is rather than specifying the type of a variable as being the concrete class, you use an interface, and then you can pass it to anywhere where, in this case, a list is required. So we would typically do list of type string mylist equals new array list. And that's fine, you know, that's a very common way of writing code. And then we pass it around, treating it as a list. If we use var, it's always going to be inferred to be that concrete type. So it will be inferred as an array list of type string. And people sometimes think, oh, well, actually, doesn't that mean that we're sort of losing some of the ability to program to an interface, and things are going to be a little bit different to the way that they were? And the answer is no, because polymorphism still works in exactly the same way. because an array list of type string is still an instance of the interface list. So everywhere that you can use a list, you can use the MyList because it's an array list of strings. So you can use it as a list. So there's absolutely no problem with that. You wanted to say anything?
Yes. So but the fact is that the fact that a concrete type is inferred does bother some people, because it's like there is this very strong notion of programming to the interface in Java. And so like that line of code near the top, you see that all the time, because it's like, okay, what that enables you to do is change the concrete implementation, and then the rest of your program still uses the interface and does not need to change it. So that's a very important and valid style, and it still works in a var world. So remember, var is local variable type inference. So if you're using var, any place that variable is used is deliberately scoped within a method or some smaller scope that you've defined. You cannot use var in places like fields or in method return types or method parameter types. And that is really where using interfaces is important. Mm-hmm. And it's important because those things actually end up being baked into the class files. And if those get changed, if you change a concrete implementation, if you bake a concrete implementation into a field, method parameter, or return type, that goes into the class file. And if you change the concrete implementation, that is potentially an incompatible change. And so if you have separately compiled stuff, will break. But var doesn't apply to those cases. It only applies to local variables. So in many cases, it's okay to have a concrete type used because you're just using it locally. And then if you're going to return this thing from somewhere, well, your method should still be declared to return list of string, not array list of string.
Yes.
And that will work. You can
Yes.
say return, you can say, return my list, and it gets upcast and converted to list of string. It still works just fine.
Yes, because if you think about it, if you're returning a list from your method, then you have to have a concrete class. You can't return something that's an interface, well, unless you're doing a lambda. Talking of lambdas, so lambdas in var. Here's an example. So we have a predicate of type string, blank line, and that's going to determine whether the string is blank or not. And we might think, well, okay, let's use var in this case. So we'll go var blank line equals and our lambda expression. But that won't work either. So it'll tell you that the lambda expression needs an explicit target type. And this makes sense because if you think about it, predicate is a functional interface. It has a single method which is going to return a Boolean. And so we can certainly say that we could infer the type as being predicate of string, and that would work. But you could just as easily create your own functional interface which has a single method that returns a Boolean. So then the compiler doesn't know, is it going to be predicate or is it going to be your particular class that matches that functional interface? So there's no way to get rid of that ambiguity. So to make that simpler, you have to have an explicit type for your lambda expression. Right, we have some puzzlers for you. And before we start, I'm going to tell you that the answer to everything is not no. So we've deliberately done this to catch, so don't just vote no because you think it's going to be.
Except for the one I gave away.
If you can spot it. Right, so we have a situation where we've got a method called calc1, we're passing in a mask, and then we're using long temp equals and a value, return temp left shifted by 6, ORed with temp, added with mask, and if it's greater than 0. So, should we use var? Yes or no? Who thinks yes? Oh, good, one person. And who thinks no? Okay, pretty much everybody else. Okay, so the answer to this is no, it's not a good idea because, as we saw earlier in terms of literals, in this case, the hexadecimal number here will fit into an int, so var will infer an int, not a long. And the result of that means that what you get if you pass in a mask which is less than 0 will give you different results depending on whether you use an explicit type or whether you use var. Because if you use long, mask less than 0 will return true. If you use var, which infers an int, then you get a mask which is less than 0 returning false. So you get different results depending on whether you use var or an explicit type. So that's why you would not use var in that particular case. So I think one of the key things here is to remember that when you're dealing with literals, you need to think carefully about how to use var. Would that be a fair,
Yeah, I think so.
fair rule? Okay, second puzzle. So in this case, what we're doing is we're creating something which is going to return a list of type string. So in our class here, or in our method, sorry, we define a list of an array list, and then we say, okay, if foo is true, then we have foo. If bar is true, then we have bar, and return the list. So should we use var? Should we use var in this case and say, okay, we can use var, let the compiler infer the type for us? Who thinks yes? Ooh, okay, now that's interesting. Who thinks no? Okay,
Okay.
we're about
Even-
split
even
50,
split.
yeah, I would say we were,
Okay.
yeah, good, because the answer is no. Beware of multiple type inference. I didn't correct the diamond operator in that case. So what we had is var list equals new array list of diamond, not of type string. So we'll infer object, and then we'll get an error, incompatible types, array list of object cannot be converted to list of string and returned. So in that case, do not use var. Third puzzler. So again, we're doing similar thing here. Now the list of type string is being an array list, diamond operator, but this time we're using a parameter to the constructor where we're using list of, and we're adding 3 values x, y, z. Same code where we add things and then we return the list. So in this case, could we use var? So who thinks we should use var in this case?
Okay, a lot of hands.
Okay, who thinks no? Oh, okay.
Couple.
Couple.
So the question is, is the question should or could? Yeah, that's an interesting question. So
Could. Yeah, okay, we
all
could.
right.
Yes.
Yeah, okay, got to fix the slide there.
Yes, you're right. Actually, yes.
Yeah.
Right. So the answer in this case is yes, we can, because multiple type inference is not a problem, because this goes back to what Stuart was saying earlier, where because we're using the parameter of the constructor, that gives the compiler enough information to figure out that the type of the array list is an array list of strings, and so you don't get array list of object, you get array list of string, and then that can be returned as a valid type of the list interface in that case. Final puzzle, puzzler 4. Right, so this one's a little bit more complicated. So in this case, what we've got here is a method which is called list removal, and it returns a list of integers. And what we're doing here is we're saying, okay, let's have a list which we create from our list of numbers. So we create a list of numbers, and then in this case, we're going to use var, and we say v equals value to remove. So we're calling another method, remove whatever v is, and then return the list. And then we've got a separate method here, static integer, which is value to remove and returns 3. Now, I've deliberately said is it's a good use of var, so not should we or could we, it's is this a good use of var? So who thinks this is a good use of var? Okay, a few people. Who thinks this is not a good use of var? Okay, right. So
Yeah, most people think it's not a good use of var.
right. And there is a good reason for why this is not a good use of var. So let's assume that you have an intern who comes to work for you. And they look at the code for value to remove, and they go, well, hang on, you're returning an integer object, and actually it's returning 3. Now, 3 is an int. So why would you return an integer object? I am going to improve this code. I'm going to refactor it and make it better. So I will change the return type to an int rather than integer. Now, you know, in most cases that would work, because auto unboxing, if you simply treat an integer object, you'll auto unbox and you'll get the 3 out of it. But we get an unexpected change in behavior of our code, because in this case, which is slightly contrived, I will admit, the remove method of the list has 2 overloaded versions, one that takes an int and one that takes an object. In this case, if we remove the int, then we're removing the element at that given index. If we remove an object, then we'll remove the first instance of that object in the list. So the effect of that is that we get different results, because if we're using var with the changed value to remove, then we're removing the changed one, so the third element, so that would be the 5. And if we're using var with the unchanged value to remove, we're removing the first 3, because it's an object, so we get 1, 5, 7, 9. So we get different results. So like I say, it's a slightly contrived example, but it does illustrate that you need to be a bit careful with use of var, because the code will still compile quite happily, still work quite happily, but give you different results. So did you want to
I don't have anything to add to this. No.
Right, guidelines for use. Do you want to? I'll let you go through this.
Oh, okay. Well,
Since you wrote them.
Yeah. Okay. So this is when var came out in JDK 10. We wrote up a set of style guidelines for this. We'll have the links on the next slide. But basically, I don't think it's worth. I mean, we only have a couple minutes left, but I think these are just concise rules for, I think, good uses of var. In the presentation we've gone through, should you use this? Should you use it here? Should you not use it here? And I think we've hit most of this already.
Yeah.
And I think there are a couple top-level things, though, which is that clarity of code is very important. Reading code is more important than writing it. So one of the things, actually, I'll get back to the design process for var. The design goal was not to minimize the number of characters you have to type at the keyboard. The design goal was to provide a feature that would make code clearer. And I think we have some examples earlier on, like that massive one with try with resources where it said, buffered reader equals new buffered reader, input stream reader, and so forth. All this redundancy and clutter and so forth, and you can get rid of a lot of that using var, and that's very nice. I think that's the clearest use cases. Also, if you have long, complicated generic types, sometimes you have to end up repeating those, and if you can use var for temporaries, it's really nice, especially if you have wildcards. Let's see, is there anything else we haven't really hit here?
var to break up chained or nested expressions?
Yeah, sometimes, so it depends on how you want to do it. I think sometimes it's interesting. People have different reactions to, say, long chain of method calls, like with streams. Some people just like to see the whole thing there. And as we noted in an early example, the intermediate types are hidden. And for some people, that's okay. You have a nice long pipeline that says, oh, I understand what's going on at every step. In other cases, well, maybe you want to break up such a pipeline and say, okay, here's the first pipeline step, here's the second pipeline step, and store an intermediate result in a variable. Well, sometimes with streams or collectors or things like that, you get this complicated generic type, and it's just a real pain to type it out. And it also clutters up the code and breaks up the flow of your method. And so that's a case where, introducing a local variable is easier here since we just use var, and then you can just go on from there. So why don't we put up the last slide with the links on it?
Yeah, so basically, conclusions-wise, local variable type, for instance, is a useful feature. I think that's fair to say that. But remember, with great power comes great responsibility. And you need to consider the implications of using var when you do that. So we've got the links there for both the style guidelines and the FAQ. So you can look through those. There's more information that Stuart has written about that you can get. Plus the slides, well, I'll put the slides up on SlideShare anyway, so that they're available there, and the recording's been made, so you'll be able to see that as well. And that is basically it. So I think we have about
a couple minutes.
So if anybody has a question,
so why don't we wind back to the
that one? Yeah, so people still have time to
Yeah. Any questions?
Yes, down there.
Yeah, and with the programming to interface change to say list equals new array list, if you use var, then since it uses the concrete type, there is a subtle difference in the emitted code because you get invoke virtuals instead of invoke interfaces. So is that a potential issue that you need to perhaps
Okay,
consider?
I'll repeat the question.
Yeah, I was gonna say, repeat the
So the question was about programming to an interface. And so if you have a local variable that used to be declared as an interface type and you use var instead, then it gets a concrete type like array list instead of list. And the questioner points out that the emitted byte code will change because invoking a method on a concrete type is invoke virtual, whereas invoking a method on a reference type is invoke interface. And so good observation. I don't know if we have actually ever observed any ill effects from that sort of thing. The semantics are almost always the same. And in fact, actually, if you look at it, the compiler might actually, the JIT compiler might compress that out because sure, it's an invoke virtual, but it was an instance of this concrete type that was just created above. So it might bypass the JIT compiler might have enough information to bypass the slightly different semantics of invoke virtual, which will end up invoking the same method. I'm sorry, the slightly different semantics of invoke interface, which you know, because you're going to invoke a virtual method on the concrete type anyway.
Yes.
So from the bytecode standpoint, yes, it does generate different bytecodes. I would actually not be surprised if the JIT compiled code ends up being the same.
Mm-hmm.
Sure, it knows more.
Yeah.
Yeah, because ultimately it's invoking the same method anyway.
Yeah,
So,
exactly.
yeah. Okay. I
Any
think we are
questions?
actually.
Are we out of time?
I think we might.
Yeah,
Yeah.
I think so.
I think we'll have to. Yeah, we'll call
All
it
right.
there. So thank you very much.
Okay, thank you.